Okay, so x squared ex dx, we're taking the antiderivative of this. This should look familiar. We just did this question in example 6. I purposely am doing the same questions so that you can actually check it back with our original answer that we got in example 6. So this is how we set this up. We make ourselves a little table, and we have a D and an I. Okay, so the D stands for differentiate. Okay, differentiate. Big word. And the I stands for integrate. Another fairly big word. Okay, so you still need to know who has to be your U and your DV part. So we still need to rely on our late rule. Okay, so when I look at this, I have an algebraic and an exponential. So that means that my algebraic is x squared is going to be first because it comes before e in the word late. Okay, so u is x squared and dv is e to the x. E to the x dx. I don't need to write the other part, the dx piece. Okay, so I just need those two parts. Okay, now you can guess it. On the left side, we're going to differentiate, and on the right side, we're going to integrate. So how far do we differentiate? We differentiate until we get to 0. Okay, so the derivative of x squared is 2x. The derivative of 2x is 2. The derivative of 2 is 0. Okay, so you differentiate until you get to 0. And then you integrate until you line up. So you just go as many rows as you differentiated. The cool part about e to the x is it doesn't matter which way you're moving, it's e to the x. So the antiderivative of e to the x is e to the x, e to the x. There it is. So we've lined these up. Now, how you find your answer is to multiply along the diagonals. Okay, so you're going to multiply along the diagonals until you run out of pieces on your integration. Okay, let's write a note. Multiply on diagonals. And let's make another note. We differentiated all the way to 0. Differentiate until 0. And here we integrate until they match. Integrate. And I don't think I need to write the other part. Okay, so here comes the answer. Is equal to. So we have our first diagonal multiplication is x squared e to the x. Our second multiplication is 2x e to the x. And our third multiplication is 2 e to the x. And the last piece, all of this, the very last piece, we haven't used yellow yet, is how do you know your signs? So you alternate positive, negative, positive. And then the 0 is not going to be used. So this is positive, negative, positive, and then of course you're going to need to have your plus c. There it is. There's the answer. So the integral of x squared ex dx is equal to x squared e to the x minus 2x e to the x plus 2 e to the power of x plus c. And we could go back to number 6 and see if we got the same answer. Where are we? Oh, maybe my numbers are wrong. Hang on. Oh yeah, here it is, number 6. I just went too far. There it is. exact same answer. What? Isn't that crazy? Okay, so once again, you are required to show all these beautiful steps on your assignment. And then you get to verify. When it says verify using the DI method, then you get to check your answer. If they don't match, you've done something wrong in one of the parts, okay? Some of you on your chapter 10 show you know, and I know that's talking to my class because, yeah, Miss Cedar's class had a different question, but some of you guys in your sigma notation question, you're like, oh, the approximation didn't work. Well, it should have. Once you integrate, they should match, okay? It means you've done something wrong. All right. If this totally made tons of sense, give it a try on this question, which we did for example 3. Okay, give it a try. So you set up your chart and think about late. Who's going to be for you? What do we have? We have an x squared, which is algebraic, and we have a trig. So our u has to be x squared. And that means sine 3x is going in the integration piece for dB. So we just did x squared, so you already know all of these. Derivative of x squared is 2x. The derivative of that is 2. The derivative of 2 is 0. Now be careful with your trig. Okay, so what is the antiderivative of sine 3x? Okay, so the antiderivative will be negative cos 3x on 3, or let's just write negative 1/3. All right, now we have to think about what is the antiderivative of cos 3x. So the antiderivative of cos is sine of the argument divided by 3, right, or 1/3, but then I have to multiply it by the previous 1/3, so this should be negative 1/9. Sign doesn't change. And then the antiderivative of sine is negative cos, okay, I know I just wrote positive, of that, divided by 3, so I have a negative 1/3 times a negative 1/9, so positive 1 on 27. Okay, you can double check my math on those. Then we're going to multiply on the diagonal, and it's really helpful just to put your signs in right away. So we have a positive, we go positive, negative, positive, and then we're going to multiply these on the diagonal. Okay, and then you can take your signs from both tables and work through the math of those. So we are doing the integral of x squared sine 3x dx is equal to, we have a positive x squared being multiplied to negative 1/3 cos 3x, and then we have a minus 2x being multiplied to negative 1/9 sine 3x. And then we have a positive 2 being multiplied to, I'm going to run out of room, 127 cos 3x plus c. And then you just tidy up your answer. So what do we get here? We get a negative 1/3 x squared cos 3x. 2 negatives make a positive, so positive 2/9 x sine 3x plus 2 on 27 cos 3x plus c. All right, and then that was example 3. So if you go all the way back to 3, can I find it better this time than I did last time? Let's see. Here it is. Okay, so we have a negative 1/3 x squared cos 3x plus 2/9 x sine 3x plus 2 on 27. I'm pretty sure that's the same answer we got right here. They match. Yay for us. So very cool little shortcut method that's handy for multiplication kind of questions. Again, please show all pieces of your assignment. I do open up your images. I do check out your assignments. I don't just go by your score, although please mark. It does help me. It's very, very, very time consuming to mark, to open up every image and mark every question. I loved the work that you guys did on your chapter 9 and your chapter 10. I did enjoy marking your work, but these longer assignments would take me a long time to mark, and it's due just before report card. So if you could take the time to mark, that would be very fantastic for me. Okay, I did add one last question here. If you wanted to try a U-Try on your own, using integration by parts. And even if you don't have to do the product rule twice, you can still verify using the DI method. If you wanted a second U-Try, and I'll write up both questions answers so you can come back and look at these. I think I had a blank page right here. Okay, so these are out of order, but here's a second question that you could try. X squared cos 4x dx. Okay, so feel free to give those a try. I'll write up the solutions if you're interested in just giving a couple questions a practice run before you try it in your assignment. All right, that's it. We have one lesson left, 11.7 volumes of revolution, which is just a funky little rule, and then we're done. And you guys have been awesome. So I'll see you for the last lesson after I video it.